Okay, students, we're at Mod 4, Topic 1, Lesson 3. We just finished the first two, so we're halfway through. You might have a quiz today or next class on the first two, or may not. I haven't decided if I'm going to give a full test for all four or give a quiz in between here. All right, so do the warm-ups. Do the warm-up, one of them at the bottom of the page here. Go ahead and hit pause and do that. When you are ready, go ahead and hit play again, and then we'll check your answers. So notice I've given you the formula in case you've forgotten, area of a rectangle, as I told you here. So if they don't put the four right angles, which is the definition of a rectangle, here for you, they could have written it up here in words. If they tell you in words it's a rectangle, then it's a rectangle regardless of what it looks like. So that's a rectangle, and that's a parallelogram, even though they didn't put the parallel symbols here. Okay, so if just know that on the DCAS as well, if they tell you in the problem itself the name of the figure, you have to go by that right there. It doesn't have to have the symbols on it. So in both cases, area is base times the height. Remember, base and height are always at right angles. They're perpendicular. So there'd be my perpendicular. So height and base, height and base. So notice they're both 13 times 6. So same answer. 13 times 6 is 78. And since it's area, we know it's squared centimeters times centimeters. Centimeters squared is like x times x is x squared from algebra 1. Centimeters times centimeters is centimeters squared. And there's your area. So exact same area for both. Okay, go ahead 2 pages. Rotating two-dimensional, 2D stands for two-dimensional shapes through space, which is three-dimensional. 655 is it. Okay, so it says sketch a three-dimensional solid formed by spinning the two-dimensional shape. So we take this rectangle right here that's attached to a pencil and start, that's the rectangle is two-dimensional, spin it on the pencil and makes it a three-dimensional object, and that creates a right cylinder. Okay, right meaning because it's vertical up and down. It's not oblique, it's not at an angle, it's not going up an angle, it's straight up and down. Right. Okay, it creates a cylinder. So a rectangle that's being spun is called a cylinder. Okay, just know that. It's on page 655. Okay. Down here, what is it when I take a disc? So this is solid all the way through. That's all solid all the way through there. A disc and spin it. It creates a sphere. Okay. You might think it's basic or not, and that's fine. Hopefully you do find it basic, but these questions are actually on the DCAS. They're going to have 1 or 2 of them. Okay, they're going to ask if I spin this shape or rotate about the x. Oftentimes they'll say rotate about the x-axis, which is the same thing as putting it on a pencil like this, or rotate about the y-axis. What is the shape that's being formed? And this you're going to actually do in calculus, okay, with just not nice shapes. It might be different curves, different parabolas. You're rotate parabolas about x-axis and y-axis as you go on to calculus. Okay, go to the next page. So here we have a triangle that's being spun. Okay, again, doesn't matter if it's over the, in this case, it'd be like the y-axis, vertical axis, spin a triangle. So they could have it like this, and they say, here's this shape right here. Spin that about the y-axis, what shape is formed? Well, it's going to be a right cone. Okay? And spin about the y-axis. Okay, so it creates it over here, and it's filled in, boom, cone. All right, go to the next page. Transition in 3 dimensions now. Okay. So it says, imagine you stack each of the geometric pancakes, that's a circle, on top of each other, name the solid formed. So I have a stack of circles, or discs, because they're filled in as well. What is that? It's called a right cylinder. It's going to create a cylinder, straight up, circle base, straight up as a cylinder. Again, it's not oblique. Oblique would be coming, if they kept coming off at an angle. He's put these pancakes like this, stacked them at an angle, then it'd be an oblique cylinder. Okay, that you end up, we'll see that later. Okay, what happens if you take a square and stack it? You get a square prism. Okay, so the reason it's called a cylinder is because it's a circle. If I stack any shape straight up, for example, or even obliquely, the same shape, congruent shape over, it's almost always a prism. The only difference is when the base is a circle, we call it a cylinder. Okay, so think of cylinder and prisms, basically the same thing, except for the prism is a polygon shape versus the cylinder is a circle base. So what do we call a triangle that's stacked straight up? A right triangular prism. You name it, it's going to be prism because against a polygon, you just name the base itself. It's a triangle base. It's a square base. So that's why it's called a square prism. It's a triangle base, and it's right. We could even call that right square prism. Okay, because it's not oblique. It's not going up at an angle. It's going straight up vertically. Or it could have been turned on its side and go straight horizontal. That's still right. If it goes up at an angle, it's oblique. Talked about these words before. Okay, go to the next page. All right. Come on. Okay. Suppose you and your classmate want to design a cake with triangular bases. So it's going. You imagine the bottom triangular base moves straight up to create the top triangular base. Okay, so again, that'd be a right triangular prism. Okay, because the polygon, just going stack of them, congruent shapes, right triangular prism. Okay, now we're adding another piece onto this, and this is on the decals. What's the shape of each lateral face? Lateral means side. Okay, so these are the lateral ones right here, and the back side that you don't see. The top and the bottom are called the bases. The side ones are called lateral, and each one of these is a face. Each side itself is a face. So a triangular right prism would have 5 faces, and the 3 lateral ones, that one, and the back one, right there, are all rectangles. Okay, so for prisms, it's going to be rectangles, as you see right here. Okay, what's the name of the rigid motion used to create the polyhedron? That's that three-dimensional shape. It just got translated up, right? Went vertically straight up. That's your translation. Okay, go ahead 2 pages. What's the shape of each lateral face of the solid figure formed by this translation? So now you're seeing how it was a translation that we answered before. What's the shape of each lateral face again on every one? Anytime it's a prism, it's a rectangle. In fact, even if it's a cylinder, it's a rectangle. Like cut out the circle piece and flatten it out, it becomes a rectangle as well. What's the name of the solid formed by this? That'd be a rectangular prism. Okay, prism is a stack of congruent shapes. Okay, everyone is congruent, just stacked up. Whether vertically, then it's right. So we could actually add the word right in front. Okay, or if it's at an angle, the same congruent shape, but up at an angle, you know, oblique rectangular prism. Okay, so if I stacked all these rectangles up at angles, it'd be the exact same rectangle, but stacked up at an angle, that'd be an oblique rectangular prism. Okay, so that's the difference. Stacked vertically or horizontally, it's right. If it's stacked up at an angle, any angle at all, outside of horizontal or vertical, then it's oblique. Go to the next page. So now you're hearing those words I've been using. You're seeing right here, right rectangular prism. Okay, if it's not perpendicular, as I said, straight up vertical or horizontal, then it's oblique rectangular prism. Okay, and we're going to look at 8 through 10. Identify the shape of each lateral face of an oblique rectangular prism. Okay, sketch an oblique rectangular prism. Okay, so I could just draw 2 rectangles, for example, like this, and then I connect again. It's solid if you can see it. Like here. Oops, that's not connected there. It's connected there. Okay. Now, I can't see this back one right here. So I dashed it. Okay, so if you can't see it through the solid figure, you dash it right there. So this one back here should be dashed as well. I want to be able to see that. Okay. So there's an oblique rectangular prism. Okay. The lateral faces, rectangles as well. Suppose you and your classmate want to design a cake with circular bases. You can imagine at the bottom circular base a disc, okay, which is a circle filled in. That's what a disc is. It's a circle filled in. It's translated straight up, so you see the word translated again. We talked about to create the top circular base. Identify the shape of the lateral face. Well, if I go ahead and cut this, a little slice right here, and then I unfold it, it's going to become a rectangle as well. Okay, one of these will be on your DCAS. You'll also have it on your test as well. They'll be asking you. Okay, what's the name of the solid formed by this translation? A right cylinder. Okay, just move that. That didn't work. I guess I'm not going to move that down. Okay. All right, building the cylinder volume formula. Okay, so now we're going to talk about volume. The volume of any cylinder or prism. Remember, those are the same things, congruent shape stacked up vertically or obliquely. It's the same congruent shape. If it's a circle base, it's called a cylinder. If it's a polygonal base, triangle, rectangle, square, heptagon, octagon, are prisms. The general formula. This is the general formula for both of them, not the specific one, the general one. That means this is the general formula that will work. Then you can break it down to specific from there. Area of the base, capital B, stands for area of the base. Remember, area is units squared. So I'm going to have two things I'm multiplying to get the area of the base, times the height, which is one length itself. And so the 2 plus the 1 gives me volume, which is cubic units. So you don't think, oh, I have a 1 here and a 1 here. No. Area of the base, area is really 2. And then plus 1 gives me a 3 for the exponent. Okay? So that's the general one. Well, what is the area of this base? It's a circle, isn't it? What's the area of a circle? Pi r squared. We already did that in warm-ups. And there's my height right there. So the specific formula for the volume of a cylinder, so that's area. So now I throw in the height in there, now it becomes the volume. So that's the area of the base, pi r squared, times the height. So that general formula becomes this specific formula for a cylinder, pi r squared h. Okay, so that's the specific formula. But you can get that from the general formula of area of the base times the height. That works for every cylinder or prism. Okay, so that's where they go ahead and tell you right here, pi r squared h. Specific formula, as I say. Okay. Cavalieri's principle now. Cavalieri's principle is an approximation of an irregular shape. Okay, consider the irregular shape. The distance across any part of the figure is the same. L, if you want to call it that, and the height. You can approximate the area by dividing the irregular shape into congruent rectangles. Okay, so they divide it into 10 congruent rectangles. So you notice it's a little bit off here, a little less here, but a little more added on there. So it basically evens out. Okay, this is what Cavalieri's principle is saying right there. All right, so go ahead 2 pages now. Consider the right rectangular prism. So that's this one because it's vertical or horizontal. And the oblique rectangular prism, this one obviously right here because it's at an angle. It's not vertical or horizontal. Okay, so you see names of them. We've already talked about that before, so that should be easy. This is on page 666. Now go ahead and go down to the bottom here. Approximate the volume of the oblique. We see it's oblique because it's up here at an angle of the oblique rectangular prism, meaning all of these are rectangles that are stacked, congruent rectangles. Since it's a prism, that means the same shape stacked. So these are all rectangles stacked into 10 congruent right prisms as shown. So again, remember the volume formula is area of the base times the height. Well, the volume for the area of a rectangle is length times width right here, right? So length times width, and then there's my height coming down from here. So the volume of a rectangular prism, it can be a right rectangular prism or oblique, doesn't matter, same answer, same formula, length times width times height. A lot of you have seen that in elementary school. Okay, but that's where it comes from, the general formula of area of the base times the height, and then the specific one. So it's the general again. There's the specific formula. Okay, remember altitude is another word for height. It's always at 9 degrees or perpendicular to the base. Go to the next page. Okay, we have a right cylinder and oblique cylinder. These have them drawn out for you. Again, it's the same formula. Area of the base times the height is the general. And again, because the area of the base of the circle, it's pi r squared h is the specific one. Okay, so pi r is just r. We don't know what it is, so it's just r squared and there's h. So there is the formula for both of them. Okay, it's important to mention that Cavalieri's principle principles do not compute exact volumes or areas. They're approximate. These principles show only that volumes or areas are equal without computing actual. Okay, go to the next page. Okay, almost done here. Explain the relationship between the volume formulas and the transformations you can use to create each solid. Okay, so a prism, remember this is the general formula for every prism or cylinder. Okay, this is a specific one for which one? Rectangular prism. Okay, specific for rectangular prism. Okay, let's go to the next one. Again, cylinder. There's the general formula, area of the base times the height. Remember, it says for cylinders and prisms because they're the same shape stacked. General, and then here's the specific one because the area of the base is a circle, so pi r squared. Okay, so that's just review right here at the end that we've already talked about, and there's the end of that lesson.